All right, radical equations. Now, radicals, same thing we've seen before. Square root, cube root, fourth root, it doesn't matter. They're just the roots. Okay. Now, one of the things that works for us with equations, since it's an equation, remember something very simple. You can do anything you want to an equation as long as you do it to both sides. Okay? Very basic stuff. We've multiplied both sides by something, added something to both sides, subtracted, whatever. So when we're looking at a radical equation, that means that the variable, in this case x, is trapped inside the radical. So it's inside square root, cube root, fourth. It doesn't matter what the root is or what the radical is, it's inside. Well, I can't solve for the variable when it's inside something. I need it outside where I can work with it. So this is where we're going to use that opposite operation. Instead of square rooting, the opposite of square rooting is squaring. So we're going to square both sides. So if I want to eliminate a square root, I'll square. And I can do that as long as I'm doing it to both sides. If I square that square root, they're canceling out, leaving you just the 3x minus 5. And over there's a 16. Makes it a nice, simple equation for us to say. I say simple. We've solved much more difficult ones than that. But not too bad at that point. We've just got to get rid of that radical. Add the 5. 21 divided by 3, 7. So if we can eliminate that radical. Now, the idea is if you square a square root, that's the opposite operation. It's going to give you this inside piece. What's really happening is the exponents. So let's look at something in this form. Let's say we had 2x plus 1 to the 1/2 equals 3. Okay. So we've seen the radicals with rational exponents. So we need to remember that a half power is the same as a square root. And the top number is the power, bottom number is the root. So this is still a square root. That means that I want to square both sides. There. 1/2. I'm going to square both sides to eliminate that square root or that half power. So this is why the square root really does eliminate. Remember your exponent rules. If you have a power raised to a power, you multiply. And a half times 2 is 1. That's why the square is canceling out the square root. So if you multiply these two, 1/2 times 2 is 1. So you really just have 2x plus 1 to the first power. Again, 9 over here, 3 squared. Subtract the 1. We got 8. Divide by 2, we got 4. Right? So again, once the radical's gone, pretty simple. Okay? Or at least back to a basic equation for us. One of the things that we have to kind of pay attention to is making sure that the radical is isolated. Right? The radical has to be isolated. So if I had something like this, let's go with the cube root, x minus 2 minus 4 is 0. I switched from a square root to a cube root. It just means we still a different root. It's still a radical. But I need this guy alone. So notice in the first two problems, it was the radical equals a number in both cases. Now I need to move that 4 over. So I have cube root x minus 2 equals 4. Get that over there out of my way. So now, if I have a cube root, the opposite of that would be a cube. So we're going to raise both sides to the third power. We're going to cube both sides. Again, my goal is to eliminate that radical. So I'm going to use this power that's opposite that root. So if I see a cube root, I'm going to use the third power. So these two will cancel. Gives me x minus 2. 4 cubed is 64. And then add my 2, I get 68. No, I don't. I get 66. That's 68. 64 plus 2, 66. So we need the radical isolated. We don't care if we see a fractional exponent identifying the root or we actually see a root. That's not going to change anything. Right? We're going to see some different looks. Let's look at something like this. Let's go 3x plus 1 to the 1/4 minus 4 equals negative 1. So that 1/4 power, that's the fourth root. Still I need it alone. So my first step is going to be to move that 4 over. So I would have 3x plus 1 to the 1/4 equals 3. If I add 4 to both sides, I get that 3. And now what power would I use? 4. We're going to go 3x plus 1. We're going to raise that guy to the 4th power. So that gives me 3x plus 1 equals 81. 3 to the 4th is 81. And from there, we're just working our equation. So let's see, subtract 1, we get 80. And so then x would be 80 over 3. And I don't care if you have fraction, decimal. It doesn't matter as far as how the answer is written. Not going to change anything. Okay, now let's look at a couple of different looks here. First off, if I had the square root of 3x plus 2 equals negative 8, this one is actually a no solution. Because a square root can't equal a negative. When we take square root of something, we get a positive. Now we got to be careful when I see something over here like on number 4. I did see it equal negative 1, but when I added the 4 over, now I've got a positive, so I'm not dealing with that situation. But the square root can't equal a negative. If you were to solve this guy out, then put the answer back in, it wouldn't work. So for example, let's see, if I square this, you get 64. Minus 2 is 62 divided by 3, so 62 thirds. Now let's put 62 thirds in. 3 times 62 thirds plus 2, that goes. That's 64, so we're going the square root of 64 is 8, not negative 8. So that square root can't equal a negative. Okay. So sometimes we get fooled like that. Any even root cannot equal a negative. So 4th root, 6th root, 8th root, something like that. An odd root can. So if I had like the cube root of 2x minus 1 equals negative 2, this I can do. A cube root can equal a negative. So I would cube both sides. Negative 2 cubed. And the reason is because if I cube a negative, it's still negative. Whereas if we squared a negative, it turns positive. So again, just some different looks here. Add the 1, negative 7. X would be negative 7 halves. And that's correct, but just remember, it's an equation. So that means you have to be able to substitute it back in. So if I put negative 7 halves in, I would have negative 7 minus 1 is negative 8. Cube root of negative 8 is negative 2, so it will work. Okay. So we got to pay attention to what's over here, what root we're taking. We need the roots isolated. They need to be alone first. Another situation that comes up that looks a little bit different to us is if I had something like this. Let's go square root 2x plus 1 equals square root 4x minus 5. I've got a root equal a root. So it really looks like I've got a problem there, but What we already said was we need the root isolated. They are isolated. I've got one on each side. Nothing wrong with it. It doesn't look that great because there's two of them, but they're alone at least. I can still do the same operation to both sides. If I want to get rid of a square root, I need to square. So if I square both sides, it's going to eliminate those radicals. 2x plus 1 equals 4x minus 5. And it looks worse to us, really, but well, now obviously I've got an equation I can solve. I've got to get my x's together. But it's definitely not something I haven't done before. So let's see, 2x, bring that over, bring my 5 over, I get 6. And then x is 3. And we can check it. Let's see, 6 plus 1 is 7. 12 minus 5, 7. Root 7 equals root 7. Good working out. So again, we get kind of a different look. Occasionally, we will see a radical equal to more than just a number. So let's do something like this. 2x minus 3 inside the square root equals 3 minus x. So instead of just equal to 3, I've got an x sitting over there. All right. The radical is still isolated. As long as it's alone, I can start working, and it is alone here, so I'm good. I'm going to do the opposite operation, so instead of a square root, I'm going to square both sides. And notice each time I've said square or whatever power we're doing to both sides, not each term. I've said both sides. So if I square that radical, pretty simple there. That's taking out the radical. I got 2x minus 3. It's that right side that's going to give me a little more work with the way that it looks. Okay? So if I square that out, I would have 9 minus 6x plus x squared. Now it looks a little strange with the 6x sitting there. Remember something like this. 3 minus x squared is the same as 3 minus x times 3 minus x. Got to start distributing or foiling that out. There's where that negative 6x is coming from. Okay? So definitely still something we've done. Not new, but we kind of forget that sometimes. Write it out, expand it out, then multiply, and that's where that 6 is coming from. Okay? Now, we've seen a two-step equation, variable on both sides. Now all of a sudden we've got a quadratic and some terms. It's okay. We've worked with that. We know how to solve that quadratic. So first I'm going to get everything together on one side. 0. We usually like our quadratic first. I'm going to put my x squared first. Let's see, move this over. Negative 2 and negative 6 is negative 8x. Plus 3 and 9 is plus 12. So when we see a quadratic inside an equation, our first thought should be get it equal to 0, and then I'm looking to factor. If I can factor that thing and solve it. Okay? Here I'll factor. X minus minus. Let's see, 2 times 6 is 12, giving me a negative 8 in the middle. Again, I'm not going to say every equation that we solve is easy, but it's definitely something we've done before. We know how to factor. Get it equal to 0 and factor. So now I'm going to say x equals 2 or 6. Okay. Now let's check these guys. We got 2 answers. We need to find out which one works, or maybe neither one of them works. Okay. Let's try the 2. Let's see. 2 times 2 is 4. Minus 3 is 1. The square root of 1 is 1. 3 minus 2 is 1. 2 is good. That guy works. Let's check 6. 6 times 2 is 12. Minus 3 is 9. Square root of 9 is 3. But 3 minus 6 is not 3. 3 minus 6 is negative 3. 6 doesn't work. Give me just that 2. I can still check them back into that original equation there. Everybody okay there?